Actually, what you see here is a rare event of two birds sitting on two geese. It's probably not very consequential, but as I'll try to argue, some very rare events can be very consequential. I teach in Warsaw University, among other courses, I teach methods of social sciences. And one of the prevailing assumptions is that we always concentrate on measures of central tendency, usually the mean, sometimes median, but it is basically believed that we need to know central tendency for prediction. If we have outliers, usually they are treated as error, as insignificant, and usually it's thrown out. Well, then, of course, we are aware that the central tendency is not everything, so then we try to estimate the dispersion. Okay, this is, I think, is true across at least, sociology, psychology, maybe economics is now currently taking a slightly different approach. Another assumption is that experiments provide the ultimate method for verifying theories. And what I'll try to do is to argue today is that these two absolutely crucial assumptions of the methods of the social sciences put a serious restriction on our ability to predict in longer time spans. In reality. Really, in reality, everything that's important is a consequence of a rare event. If you want to predict the real world, you can forget the average and just concentrate on the outliers. Not only rare events are the most consequential, but the more rare the event, the more important consequences it may have. It, of course, does not mean that all rare events have important consequences. The vast majority of them doesn't have them, and one of the questions that I'll try to answer today is how we can understand that only some of them are that consequential. Well, for example, stock markets are defined by bubbles and crashes. I mean, there is clear role of catastrophe in social dynamics, wars, interventions, and so on. And really, social sciences currently do not have tools to describe and to basically deal this, measure and estimate and input into their theories rare events in a different than simply descriptive way. Well, this is I borrowed this slide from Serene. And, well, basically his favorite scientist, Phil Anderson, says that real world is controlled by the exceptional, not the mean, by the catastrophe, not the steady drip, by the very rich, not the middle class, and we need to free ourselves from average thinking. Well, I think that one important distinction that the notion of rare events brings is the distinction between life and lab. Well, one rarely can observe a rare event in a lab. If one does, rare events is usually discarded as an error or basically as something out of interest. However, because of the sheer size, in real world, rare events are happening all the time in different forms. So I think intuitively this is clear, obvious. Our personal lives are dominated are basically dictated by rare events, right? I mean, I have asked a number of people, how did you meet your husband and wife? And I have not yet gotten a different answer than by extremely rare event. I was talking to one person who was saying, well, rare events are not important. And then I asked, okay, so how do you meet your wife? Oh, you wouldn't believe what a rare event it was. Okay, how do you find your job? Oh, you wouldn't believe the circumstances, So basically, I think this is very, very clear. Well, and for example, what's the probability that you inherited exactly your combination of genes? It's close to 0, right? So these are just kind of anecdotal observations so far. What are rare events? What is the notion of rare events here? Well, basically, these are highly improbable events, and I'm interested in such highly improbable events that are really consequential. So I would say low probability, high salience. Well, Taleb has published the book called The Black Swan. And the Black Swan effect, in this book, he argues that really the tails of the distributions are most important. For example, one of his examples is that if we took a single day of the fastest growth out of the stock market dynamics, the stock market value would drop by half, right? So really one single event may, in principle, have incredible consequences. Well, another of his example is a case of a chicken. Well, that linear extrapolation fails. I mean, his example is, I think he uses the example of not of chicken, of a turkey. And then generally the idea is that turkey is being fed every day, yes, and the extrapolation for turkey is that humans are friends, are feeding, taking care, and then the Thanksgiving comes, right? So basically, here is where the linear extrapolation fails. Well, he argues for the importance of rare events, but his argument is that we can detect a rare consequential event only after the fact. So you always have, it's impossible to tell in the future which events are going to be consequential, but we can, looking back, it is of course trivial because we have data, we can trace the rare events. So, well, today I'll try to argue that there is more to rare events than just the tails of the distribution. Well, first of all, rare events happen all the time. Only some rare events are consequential, and the vast majority of them don't have any noticeable consequences. And I'll today present the alphabet model that we developed with Serene, and which may provide with formalists to describe at least one mechanism of the importance of rare events. If you look at the literature on rare events, there are really two kinds of rare events. The first type of rare events is something that are called strong rare events. I mean, this is a consequential event as soon as it happens, right? I mean, they're strong. They're, for example, any catastrophic change. So war, big political changes such as the collapse of the Soviet bloc, stock market crashes, industrial catastrophes, changes of technology, such as the introduction of internet. It happened only once, but it has changed basically social dynamics in a very profound way. Fusions and takeover of firms, disastrous epidemics, all kinds of natural disasters. Well, when we see it, it's immediately apparent that we are dealing with a rare event. Well, and their mechanism is relatively well understood. For example, Dirk Helbing has a paper on this, and basically it is believed that one of the most important mechanisms underlying this type of rare events is the sudden development or strengthening of positive feedback loops. So things that are relatively independent start to kind of develop positive feedback loop. One thing feeds into another, which grows to, which leads to kind of explosion or, catastrophic change. I'm much more interested. Okay, maybe I should mention one notion. One thing that is not clear, and there are two schools of view of this. I say the dominant school is that rare events are just fat tails. Well, every distribution has a tail, and basically, so there's nothing special about rare events other than they're very big. They just belong to the tail. However, there's another view, and for example, the VideoLectures NET argues for, that in addition to a general process generating the distribution, there's another process that underlies the rare events. We can detect it, and there are discontinuities. And yesterday, you even discussed first about some mathematical models underlying, detection of how we can detect a different type of event rather than belonging to the tail of the distribution. As a social scientist, I'm really intrigued by the idea that very soft, almost unnoticeable factors and events can have the most consequential, have the strongest consequences. Think about it. In the August of, in Poland, Lech Wałęsa jumps the fence of Gdańsk shipyard. Who would think that this is the beginning of the collapse of the Soviet bloc, right? There is a strike. There is a strike for going on in Poland. I mean, there's a very bad economic situation. Well, one guy jumps the fence. Somehow, this starts the chain of events that eventually leads to establishment of solidarity. Lech Wałęsa is the legendary. Yes.
No, of course. I mean, you could also think. I don't know this particular case, but one may tell other stories, or other events which would have prohibited, I mean, would have changed the story in the same way. So you are saying there are weak events which have a huge weight on the consequences.
Yes.
But there may be a large number.
Sure. There may be a large number of them. And especially, they must occur in the right, I would say, context. They must occur in the right consequences. Here we can trace simply the situation where Lech Wałęsa, he was in contact with intellectuals. So he brought to to the people who were striking in the Gdańsk shipyard an idea to start not to just demand the lowering of prices, but the creation of independent unions. So which resulted in the creation of solidarity, which resulted then with the first huge organization out of communist control in any country of the Soviet bloc. And then in consequence, I mean, it resulted in free elections in Poland, in which the Communist Party lost power, and which ended up in economic reform. In the meantime, this has sparked, this started the process in Germany, which resulted in the fall down of the wall. So of course you can show different things, right? Because then but I think that we can clearly trace and say the causal link between very significant event. And of course, I mean, my point is that many people, of course, have jumped the fences and no, nothing has fallen down. Maybe the fence, right? Yes.
Just to understand your point, what's the difference between this approach and just considering an autoregressive process with infinite memory, for example, a unity root process, in which I have a shock which has an infinite memory, so I have a cumulative process?
Sure. I mean, this is I would say that this is any process as I'll try. Why don't I present the model, okay? And then we can talk about. I'm now giving just the examples. Okay. So I'm not talking about the models. So basically, another example is that some historians, and I don't know how general this believe that really the existence of Portugal may be attributed to a single man and a single poem, Luís de Camões, and his epic poem Les Lusíadas. I mean, this time Portugal was strongly dependent, on Spain, and basically people didn't have supposedly too much notion of identity. And then there was this poem describing, the epic poem describing, a sailor. I mean, basically a nation of sailors who were brave, liked to drink wine, liked adventure. It's a very attractive, kind of image-building poem. And supposedly this created, the national identity. We're different, right? There's something that unites us, which later resulted in the creation of independent Portugal. Well, if you think about Poland was kind of reestablished after almost 100 years, and it can be probably argued that the tradition introduced by our three great romantic poets, Mickiewicz, Słowacki, and Norwid, by the way, who disliked each other, but they all kind of worked in Paris and wrote poems. And but anyway, they wrote wonderful poems that kind of carried this spirit of basically culture, right? And I think that this is really, it can be probably argued that that three people and their poems were more important than the number of armies that Poland had in different uprisings. Well, if you think about Polish science, I mean, I don't know if you are familiar with Polish School of Functional Analysis, but I think it can be argued that this is what Polish science is really known for. And it's really the fact that, several people I think I hear 7 of them, met in Szkocka coffee shop in Lwów, right? I mean, where they were scribbling over napkins and discussing about mathematics, was established, the School of Functional Analysis, which was much more important for Polish science than, billions spent on kind of, on grants, on different scientific grants, because I think it's what really Polish science is known, right? So, just as flashing another example, meeting of several individuals who agreed to paint light, right, and around Montmartre was more consequential than thousands of schools in which, very qualified teachers were painting, students how to paint properly. Well, we could go on with this examples. Well, one of the things is that, so where do we see these rare events? Well, first thing, we clearly see it in the power law and scale-free distributions. So clearly, I mean, the nature of scale-free distribution, I think, I don't need to explain it here, right? I mean, maybe this is a distribution that results usually from the autocatalytic process. This is describing to your autoregressive models, right? It basically means that this is the frequency, this is the value, and it means that, well, in many events in which you have in many distributions that are produced by autocatalytic process, really you have very few, very strong elements. They're so strong that there are very few of them. They influence the overall mean and kind of, they're very significant, in the general population. And let me show you some maybe examples. Clearly in social networks, this is from our data on Polish communicators. This is research done by Dominik Batorski in his PhD with me. It's about on 5 million users of Gadu-Gadu, the largest Polish communication. This distribution, this is basically distribution of links. And what you can see is that basically there are few nodes, that most of the nodes have about 5-7 contacts, but you have few nodes that have over 400 contacts. Right? And then, excuse me, this is... Okay. How we can use this, why this is important? Well, this is kind of a social experiment carried out using an internet game it was done by students of one of the schools where I teach, Warsaw School for Social Psychology, collaborating with the firm 1-2-Tribe. And the idea is that 1-2-Tribe produced a game. It's called CyberMech. This game is being played on cellular phones. Okay, this is one of the screens from the game. You play a kind of a character, an avatar, right? And you play it on your cell phone. And you play with other people who are in your physical neighborhood. You see them, you can form alliances, you can, declare wars, you can, all kinds of, game, right? You can see people running around, punching on their cell phones. In Poland, it's likely they're playing CyberMech, right? It's 50,000 euros for this game. Now they have other game, but this was their first game. The game is constructed. This is the map of Poland with users, right? So you can see that users are concentrated, around towns, right? You can see the people who are currently on in the game. Well, map of Poland is transformed into galaxy with different planets or planetary system, right? And then you are in a given planet. And there's the whole stories about it. Okay, now what was done in this particular experiments, SMS message was sent to a few hundred people with the highest degree, who had most contacts as a result of analyzing of this game behavior, with the idea to do a major duel between the clans at 8 p.m. What you can see is that indeed the message was distributed exactly at 12, right, at noon, and you can see that exactly at 8, the traffic increased by more than an order of magnitude. Which, if you think about the number of players, this is really quite significant results, right? You address very small percentage of nodes, and you get order of magnitude amplification in the traffic. What you can see here, this is the traffic number of sent SMSs between the supernodes, the super hubs. What you can see is that they started to communicate at 12, basically. They peaked their communication about 6, right? And then they switched off till the actual event. So this is like the preparation. So here you can see the mobilization of the network, right? Which later result in a really rare event, of 10-fold increase or 12-fold increase in the traffic, which was kind of controlled in a controlled experiment. In terms of, as another example, from a different mechanism, but I just like to mention that in the area of networks, it is all well-known fact by Granovetter that really, that the most important are not our stronger links, but our so-called weak links very often going outside of our social clusters and resulting from, let's say, chance meetings. So this brings us to another type of rare events, which are rare individuals. Often there are people who cause macroscopically visible social change, are called social entrepreneurs. I have several cases. At any moment, if you get bored at any moment, just, I can skip the rest of the cases and go on. Okay? So I'll start from some Polish cases. So basically, why it's rare? Well, Ashoka, which is a foundation helping social entrepreneurs, estimates, by their estimates, there's annually one person in 10 million, basically in every country, it's almost independent of the country, that fulfills the condition of, individual action, causing macro visible scale. Social change visible macro scale. So it's really rare, 1 in 10 million, right? Okay, this is Valley of Strug in County Chmielnik, Województwo Podkarpackie. This is not far from Krakow. In the 80s and early 90s, there were isolated poor farms, and where there are negative attitudes toward any type of cooperation, any type of initiatives. There's a history of failed initiatives of kind of communists. They had negative attitudes toward any type of common enterprises because they were associated with the communist, common farms and so on. There's very bad education system, and there's high and growing alcoholism. So basically, nothing really could be done there. It seemed like, a helpless case. Then Kaz Jaworski had the idea to start an independent telephone system. This was before the cell phones were really popular, right? So telephone in Poland was a very valued property, right? You had to wait sometimes years in line till you get a telephone number. Somehow, through a foundation, he was able to get the first independent system in Poland. There was 8,500 households connected with free local calls. The idea was that you're paying only for outgoing calls. So people could communicate for free, which creates, of course, social capital. People start to talk, right? And it's easy. It doesn't cost anything. And, of course, everyone wants a free phone, right? Beautiful new phone, right? Well, okay. So then, as soon as the phone is in, he gets an idea, that there are sick people who die because the ambulances don't get in time. So the idea is that people who have heart problems get telocardiomat. He started telocardiomat. Basically, people get electrodes and a modem. Whenever they feel sick, they kind of plug in the modem. They attach the electrodes, plug it, cables into the modem, and call the local hospital. Doctor looks on his monitor and decides, you just ate too much today, or maybe you're really sick, you're sending an ambulance, right? So this is. Then there is an internet broadband access. Well, people start to talk together. There is a common success. So in the next step, the telephone system is used to create the direct sales system. So farmers can sell the product directly to the nearby town. And people in the town can order, let's say, 12 eggs and, let's say, half kilogram of cheese, right, from a particular farmer. And it starts to develop into a system, which right now has 100 trucks Yes, and this is, and basically everyone is happy because farmers really, get full price for their products, and people get, really fresh products directly from the village. Somehow he was able to persuade people to which is not easy in rural areas in Poland, to invest in a sewage treatment system. Next thing is basically, so right now this direct sale for this is an enterprise at 100 trucks, 500 employees, 100,000 customers. The sewage treatment, was another success. And another step was they discovered sources of mineral water. They started production of mineral water and selling, water. Money was used to bring information technology instruction in schools. One of interesting, and he also, well, basically I'm saying he's really, community that was created around him, had the ideas, well, to also deal with social problems. So, for example, to deal with aggression, they introduced dance lessons for boys. Because one of the, despite the huge economic growth, the local problem was aggression among teenagers. Well, it turns out that aggression was caused by boys who couldn't dance. There was a big, social event. Boys that couldn't dance were getting frustrated drinking, and then they would start up a fight that would then have repercussions in the months to come. Actually, teaching them the dance solved the aggression problem. Another one, they also started, a special program to deal with alcohol drinking. Basically, in 10 years, the number of enterprises grew from 200 to 900. And also, as I'll show you, percent of votes for EU access doubled compared to the other neighboring areas. This is basically so you can see that he created a system that really includes farmers, schools, local government, businessmen, firms with high-tech internet. This is, you can see, a court case against alcoholism here, right? This is one of the ways to, high school children have kind of conduct, well, this is one of the social initiatives. This is how it looks today. Okay. This is voting for EU access. This is County of Khmelnyk. This is visualization by Kamil, who is here. So you can see that there was 36% basically, and 27% was the next highest. So you can see on a macro level, right, the effects of individual actions. Maybe I'll skip this. Excuse me, I'm going the wrong direction. Okay. Another thing of my favorite examples, I'll go very, very shortly about this. This is Żegocin in Województwie Małopolskie. It is basic, It is Dagmara Bieńkowska. And there was a country that was very poor, that split as a result of well-managed social intervention, split into two counties, the richer part, Trzcianka, and the poorer one, Żegocin. It was so poor, they didn't have anything. So Dagmara Bieńkowska came there as a teacher, and she started for 1 month. She looked, and she was everywhere talking to people. What resources do they have in excess? What they can base their change on? Turned out that she couldn't find anything. The only thing that they had enough were old people waiting to die in their homes. Okay. So the idea, if this is what we have, we need to base our social change on what we have. So she designed a program in which was aimed at producing a cookbook, okay? Because they didn't have, forests, very nice forests, didn't have nice rivers, no lake, but it looked like for them the only chance maybe tourists. But, why would tourists come to Żegocin? Well, maybe we have a tradition. What kind of a tradition we have? We don't have much history place, but we had, there was this very good culinary tradition. We knew how to cook before the war, yes? So the young people, and look at this, young people from one families would come to visit old people in other families to ask for the local recipes for food. So the old grandmother would kind of, get out of her bed, right? And say, okay, the way to bake a bread was, and she would then go on, right? Not only that, the next day she would get out of her bed and walk to their neighbor's house, saying, I forgot to tell you that you need a horseradish leaf on which you can put your bread, right? So suddenly you see that other people are taking care of your family, right? I mean, they're making them, happy. So basically, kind of, people start to trust each other. They start to do things together. And I don't want to here to get into details, but today, the poorest part is doing much better in economics terms than the original one that has split, that Chanka, who was much richer and took all the resources. Because they cooperate and they do, stuff together. So maybe I'll skip Dorota Komornicka. She does projects thinking for children. This is another of my favorite examples. During the communist times, there was a project. Around Warsaw, near Warsaw, we have a very nice forest, like a preserve, Puszcza Kampinoska. And there's an idea to make in the center of this agricultural farm for the Communist Party. And there was the guy, Piotr Topiński, he's a biologist, and his idea was to save this forest. And he used some creativity. What he did, he introduced 3 beavers. After, really, kind of looking into what was happening in the region, he decided that 3 beavers would do the job. So he introduced 3 beavers. The beavers, in the time, built dams. The dams had seen the terrain that was supposed to be, the location of the farm. And because they're endangered species, no one could do anything with them. And this is so somehow, somehow the forest was saved. Mir Hassan from Bangladesh. I mean, basically, initially in Bangladesh, there was no math and no demand for math texts and no demand to learn math. However, he had a dream. That math was so important and that basically the future of the country depends on, people knowing math. So he has decided to kind of start a math movement, but not to teach people math, but to turn math into kind of festivities, to build a culture of math. So he would do math Olympics, he would do math festivals, right? So there were evenings, bonfires. There was an honor code. There was, a lot of competitions, and I mean, there was math in newspapers. There was training of teachers. Here's the day of open. You can see here, children are a special event in which children can ask their teachers, anything connected to math, and math became really big. So basically, you see exponential growth of math festivals, exponential growth of math publication, and participation in international math festivals. So again, you can see that because of a single person, a country has made a very significant step in education. This may be the last one I want to show you. Is that this is Volage Barpak in Himalayan region of Gurkha. This is basically a very poor region, and there seemed to be an almost irreversible immigration trend. People just were leaving it, going to others, the local culture was dying. So, basically you have beer. So there's beer Bahadur Gale, and his idea was to use water turbines that would produce electricity. So no one was interested in this, no one really wanted to do it, so he used all his funds, he borrowed money from his friends, he went all practically bankrupt, but at some moment he started some electricity, right? I mean, so there were some street lamps, and suddenly, bakery connected to this. And this idea his idea resulted in 1,400 villages having small electrical turbines in 59 regions in Himalayas. So this is, again, visible on macro level. And the whole idea is that he started a social process around a single idea that kind of amplified, because right now, I mean, they don't have to travel to, for example, to get bread because they have local bakeries that operate on this. I mean, they have electricity to have TV and radio and internet access. And I mean, I don't need to get into this because I think this is clear. This is self-evident. Again, a single person. This is one person, like, okay, maybe I don't have time to get into other ideas. Maybe I'll just end with probably the best known social entrepreneur, right? This is basically Muhammad Yunus and the Grameen Bank. So these are unique individuals. Now we have unique growth centers. And this is what I would like to concentrate for now and use the example of the work that Camille started as my other student, Kuba Urbaniak, and then we continued with Gur and with Sorin. So basically, what is known is that there are local effects in economy, such as spatial clustering of innovation, spatial clustering of farming practices, and so on, clustering of industries, rent agreements in farming, and so on. And what basically in economy, it was traditionally by Weber attributed to the cost of transportation, and by Thunen, Van Thunen by the rent of location. Then Peru defined the notion of the growth pulse. Then simply say, well, the growth is appearing through growth pulse, and we have this propulsive positive and negative propulsive trends. And then Myrdal started this notion of frozen accident that was later, formally defined by Brian Arthur, and who said that basically there is, because of circulative and cumulative character, not only of economic development but also of human society as a whole, so economic growth has natural tendency for spatial concentration polarization. And quite often the development of particular regions had their origins in historical events of often accidental character that started the process of cumulative causation. Arthur says that any model with local positive influences will cluster. And once it clusters, it will continue to propagate in time. So basically, it's again the role of frozen accident. So in 1990, in Poland, Balcerowicz introduced reform after the fall down of communism that really reformed Polish economy from centrally governed to market economy. So now I would like to show you a model how we can think about the growth process and then compare it to Polish data. So this is the alphabet model. So it starts from the famous, I think that many of you know the model, the model that I think Sorin is famous for this, right, in his group, the model of autocratic growth process. So we have the catalytic agents B and a growing catalytic agent A and a growing agent B. And basically the idea is that they exist on a spatial lattice, and B can multiply in the local presence of A. Okay? So basically this is A, B happens on the same site as A, and then another B is produced, right? And I think that you have been, I will not, that I think you have been exposed. Have you been exposed to this presentation of Sorin and his group? Yes? So basically the idea is that, the idea is that basically this process has very different properties from the average process. In the average process, if you average the number of A's and B's, in many conditions simply there's not enough A's to support the growth of B's, if you average it. However, if you have a spatially concentrated model, it is if you have large lattice, even extremely rare air can support the growth of B. So basically the continuous prediction is always wrong. This is Sorin's slide. And basically I can show you, well, I probably don't have time to show, well, maybe shortly I'll show you the working of the model because it has some some interesting properties. Okay. So I cannot get to this. I think I need to get. I'm not sure it's English because I cannot get to the start button. Somehow it is the screen resolution is too low for this. Okay, so. Okay, so back to. Well, generally the idea is basically that in the places in the whole space, where if you have a space and the B is randomly distributed on this, the growing agent is randomly distributed on the lattice, in the places where A is present, the B will multiply in an exponential rate. So what means simply that it will produce such quantities that basically compensates the fact that in all other places B dies. So the basic idea is that local growth just kind of governs the global dynamics. Okay. Now the alphabet model is an elaboration of this model, and that allows us to connect it to social theories. So really in the social sciences, we usually do not have a single growth agent, but we have a number of factors that decide about the growth rate. And this is coming back to this regression question, right? The thing is that, so we have a dynamical variable B, and we have collection of letters, A, C, D, Z, and and as many as you want, right? That decide about the growth, the rate of growth of B. So it's what, in this discrete model, the probability with which the B will produce another B, right? Which basically may say it's the rate of the process. By the way, this is a general also, each of the letters diffuses with some probability, specifically B diffuses. So the letters also can be produced by this process, what basically puts us in the formalities of reaction diffusion models. Now, so basically the idea is that now we have three letters. AB is not enough to multiply, right? But if B, A and C is in the same place, now new B may be produced, right? Now, this is a new view on the causality that is typically used in social process because you have, usually the A causes B. Here is that we have a rate of the process. This is kind of, modeled much closer to economics than sociology. And basically here the idea is that causal factor is one that affects the rate of growth. Now it's possible to relate it to empirical data and no theoretical effects in the social sciences. I think the most important fact is that, as Taleb puts it, rare events are so rare that basically you cannot measure them, you cannot make meaningful statistics. I mean, you have to just wait for them and explain them after the fact. Here, each of the specific quantities may be measurable, but their conjunction may form extremely rare events. There is, in the literature, there is this, yes?
No, I didn't understand the model. So, I sort of got an idea that new types of agents are created, but I didn't understand the rules of...
Okay. The rules are that for B to multiply, it needs some combination of other letters to be present.
Okay, these are rule which is frozen? Or,
Pardon?
These are rule which is defined from the beginning?
Yes, this is the rule that is defined from the beginning. So the only thing that I should maybe ask is that production of B is specified with a certain probability. So we may say that that in the presence of A and C, with a certain probability, B will be produced. Okay? Now we can say that this probability depends on the combination of the letters. So for every combination of the letters, we can specify the probability that the multiplying agent will multiply. The growth agent will multiply. Is it clear now?
Is it possible to move these letters?
Yes. Each of the letters diffuses with the given probability. So simply their local coexistence is only temporary, which is very important for the model.
The rules are the same for all sides.
The rules are the same for all sides, but the concentrations of agents doesn't necessarily change. It's very local.
And the aids also, they can reproduce and die?
The aids by themselves here, in the simplest version of the model, you can write a model that aids will reproduce and die. In the simplest version of the model, we have just one growing agent and several catalytic agents. But of course, you can write any form of equations, of rules, that some letters can produce other letters. Okay. So now, how does it allow us to deal with rare events? Well, each of the specific factors may be measurable, right? So, however, the conjunctions of these events may be extremely rare. Nevertheless, we can estimate it based on two factors: the relative frequency of each of the factors and their tendency to co-occur. Right? So we have correlation between factors, it's one factor, and their frequency is another factor. They define as the probability of rare events. So basically, we can start from something measurable and still deal with the rare events. Now, another important property of the model, maybe I'll tell, okay. Another important property of the model is because all the factors can decay or move, that the length of the growth, the time of the growth, is limited by the existence of local condition, right? Like the growth of the fear may depend on, let's say, the length of the same time. You need, let's say, both materials to produce and demand, right? If these two things are no longer together, the process locally stops. So, how can we see it? Well, let's look at the Polish economic transformation, and I'll argue for the role of three factors: education, east-west orientation, well, there's four factors: history and social influence, as specific letters influencing the growth. So I try to argue that various factors define a very well-defined process, hard process of economic growth. This is the work which was published in this year with Sorin and Gore and Camille. So basically what you see is in all the countries of post-Soviet bloc, you see the same general pattern of economic activity following the transition. You see initial decline followed by very fast decline followed by the growth process, so-called J-curve. As you can see, Poland has done the best. I mean, the decline was smallest and the recovery was strongest. Right? This is the top one is Poland. Well, how does it fit the model? So basically, the first days, if you start from centrally governed economy that is supported by central mechanism, and you withdraw the support factor, everywhere where there are no local conditions for growth, activity will go down. In the other places, activity will shoot. In the few selected places where you have all the factors for growth, the activity will go up. But initial values of a fast exponential process are small. So before they get big, the outgrowing majority, the sheer number of decay places, will cause general decay. So basically, if you look at the map of Polish economy, this is the centrally governed economy in '89. This is in the '90s. This is the year when reform was introduced. I mean, the darker, the more red, the better off. This is number of data per capita, privately owned enterprises per capita. You can see kind of a thinning down of economy. I mean, there's nothing happening much.
How do you define economy?
No, this is number of privately owned enterprises, privately owned firms per capita. So probability is the single individual basically owns a firm. So, by the way, it's extremely highly correlated with income. So this is, Now, this is the same country after 1 year. You can see, by the way, this is a logarithmic scale. So this is really accenting the lower end of the scale. I mean, as you'll see, these points, when you take the linear scale, it becomes extremely small. But you can see that basically the growth in most of the Poland is decaying, right? This is the year of the strongest decay. But still, you can see very strong growth in well-defined places, right? But as you can see in '92, the growth spreads from the centers to the rest of the country. Okay. This is very different measure. Voting for pro-reformist parties, right? Another correlated process, and then you can see. I mean, pro-reformist means pro-free market, pro-market, and you can see totally different index, not the number, but from totally different registry. As you can see, these two maps are almost identical, right? So this is not a single process. This is basically a whole different systems being established in specific places. And we, as we call it somewhere else, social transition occurs through bubbles. I mean, bubbles are very much like phase transitions in physics. Bubbles of mu appear in the sea of alt, right, and they expand. Now, what you can see, this is, by the way, this is discovery of Camille in his master's work. And this is simply education in Poland in 1988, before the election, before the transformation. You can see that the election, that the number of the education in the preceding years will determine the shape of the process in the years to come. So this answers the question, does it make sense to invest in education, right? So clearly education is one of the crucial catalytic factors, right, for economic process to take place. You can see here that this is the growth in the most educated countries, this is the growth in the poorest countries, right? You can see that only the 4 highest classes in educations grow, the rest decays. Yes, again, analyzed by Camille. This is, you can see what happens in a map. This is a logarithmic scale map, year after year, 1989 to 2004. What you can see is that all the growth is occurring in quite well-defined places, yes? Then you can see a new process, offset in time, that you see growth coming from the west, from Germany, right? Just like a diffusion from Germany. Look now to the left, this is the left side of the map. Yes, which it becomes. Can you see this right now, that there's growth of the existing centers plus a new process of diffusion? And basically you can see that till 2004, basically this is how Poland got transformed. This is a different scale. This is a different scale. This is okay, doesn't matter. So this is the rate of growth. What you can see here is that this is 18, this is the year of the transition, where basically you get very fast growth, and you can see that these growth rates kind of get equalized. Now you have fastest growth on the west, but then you have basically similar growth rates. Okay. Now, here I have comparison of the singularities. Sorry, let me try to page up. I don't know why I cannot go up. Okay. So what you can see here is number of economic enterprise per capita in 89. This is in 94, and this is education in 88. Right? So really you can see that economic growth, this is linear scale, it's not logarithmic scale anymore. What you can see is that growth in Poland really occurred in extremely well-defined singular places. We are here, education is simply number of years. So secondary school, let's say 7 is 8 years, yes? And then let's say, and or the primary school is 8 years. And then, high school is an additional 4 years. Bachelor is 3 years. So what we are doing for every country, we are measuring number of years spent in the educational system by the average citizen. And this is the strongest predictor. Its correlation is about, depending on how you measure this, around 0.7 with the economic growth. You can look here. This is the growth rate of the fastest. This is the growth of the fastest of the most educated regions. This is of less educated regions. This is just 16 counties with the highest education level. That's a very good question. Here, this is my slide. So here, it does correlate with population density. This is simply there. So the red is education, and education minus population, with population density partialed out, by partial correlation. This is with population, and this is with population minus education. So it does correlate with population somewhat, but clearly the education has a very strong effect, in addition to population, but not vice versa. So this is again, maybe I should go through this and get to Some other, okay. This is the distance from Polish-German border. You can see these are years. Negative correlation because the further from the distance, the less enterprises. So this is basically rotation of the Poland to the west. You can see that basically it starts from zero correlation. But really, this correlation develops over years, and in 95, it basically becomes 96. In 96, it becomes fully developed, doesn't change anymore. Okay, I should. Okay, so. And this is now social influence. So the presence, local presence of other actors who have already, started enterprise. It's basically kind of looking at the measure of spatial correlation. And you can see that initially, this is in 89, there was no spatial structure to entrepreneurship. In 90, there was no spatial structure. Then in single year, in a process extremely resembles phase transition, suddenly you see the onset of correlation, which becomes 0.7. It stays the same for the next years. Okay? So 0.7 for neighboring counties, and basically the length of the correlation coefficient is about 90 kilometers, what means that radius of the cluster, the length of influence, about 45 kilometers, about 1 hour of driving. This is this is Moran's I. More systematically, you can see this how it changes in years. The spatial correlation function, you can see that it was very low in the beginning, and then it went up. This is space plus time. So, with interviews with firm owners, we have confirmed that interaction with other people form a crucial mechanism for the influence. And the last factor is culture. I mean, this is how Poland was divided before the First War, or basically how Poland was, Polish composition of, now this is basically Silesian, Galician, this is part that we got after the war from, that is recovered land from Germany. This is also recovered land of Germany. This used to be Russian for about 100 years ago. So basically, what you can see is kind of how Poland looked about 100 years ago. If you look at how Poland was partitioned between Russia, Germany, and Russia, Prussia, and Austria, and generally how this is, and then with some addition of new borders. Now look, first of all, this is how it looks in terms of education. But now, this is what you can see in terms of economic growth. You can clearly see both in weighted average by population and unweighted average that basically Prussia and Silesia do better than Russia and Galicia, right? This is the difference. Not a strong effect as education, but quite significant effect. Here's the map of Poland. This is frequency of voting in EU referendum. And I would like to show you a few maps of voting. So this is voting for pro-market parties in 91, okay, with the division of Poland. Look, you can predict how people will vote with accuracy of 10%. Well, 10 kilometers, not percent, 10 kilometers, depending on where this part of Poland belonged 100 years ago. So this is the soft effects of cultures, I think, that are being, not only because probably social mobility and kind of entrepreneurship, but at least some of this is clearly affects locally transmitted effects of culture. This is election in 93. This is EU referendum. Look, I mean, you basically see, right, how Poland was divided before the First World War, 100 years ago. So I must tell you that when I first saw this result, we were absolutely shocked by that. You are quite interested in these results, right? So, anyway, we did factor analysis on voting patterns, and there's an economic pattern that basically follows. There are two factors in all Polish elections between 89 and recent. And one factor is basically economic factor, this is what you see. Another factor is a political factor that has very different spatial structure. It's basically church versus kind of, versus, I would say, this is the value factor, basically. So, what can you say about the alphabet model? The rate of growth in longer time spans is critical for prediction. Local combination of growth factors decides about the rate of growth. Each letter of alphabet corresponds to a particular factor, and the length of the time of local coexistence for growth factors is a critical factor limiting the level of growth. So basically, I mean, if you want to predict in longer time spans, you should look for the fastest growing element or elements, because really you can almost neglect the rest in your predictions. And then really you have to think about how long will the factors facilitating the growth coexist together in these locations. Thank you.
We have time for one question. Who's volunteering?
I just want to make a comment, which is that our thinking is very much influenced by the equilibrium or steady state considerations. And in fact, if you have an equilibrium, then rare events don't matter. And what is different here, what you said, but perhaps not emphasized enough, that these are not equilibrium systems.
There's a transition between different
Where
equilibriums.
you
Right?
have growth and strongly dynamic effects. And in this case, of course, a rate event may change the direction of growth and everything. And you may add to your collection of that's a very nice short story by Bradbury, when there were huntings organized in the past, but it was allowed only to shoot an individual of a species which is just before dying out, just before extinction. And the guy made a mistake and totally changed the history of it.
Okay.
Can you also, I mean, do you see any regularity in how agents change the working pattern? I mean, how the diffusion of, because, I mean, to some extent, I mean, everywhere, in every country, there are regions who are more, one part than the other. The important thing is, I think, to see how, if there are diffusion processes in the changes.
Yes, this is, we could very clearly see for this modeling, as I mentioned, I mean, I was quite clear on this short on this modeling part because I wanted to emphasize the empirical findings, which I think is most interesting. But really to model what we, really actual model and actual published model is based in form of differential equations, not this discrete model. But what is done is that you need to assume that basically you have exponential growth process to match the data. You have exponential growth process in very selected locations. And then you have strong diffusions, to neighboring locations. So actually, for every step of production, you have two steps of diffusion, and then you get, and then basically you get, the reproduction of empirical data. So clearly, clearly diffusion is very important. I think that, however, it's also important that the diffusion is not too strong, because if you introduce too strong diffusion in form of taxation or other, other mechanisms, then what will happen? You will stop the growth. So, of course, if there was no diffusion, there would be no benefits to the rest from the growth centers. So the whole idea is to kind of diffuse enough, to let everyone else be happy, but not to stop the growth process.
Thank you very much.
Okay, thank you.